Okay, ladies and gentlemen, we are moving on to systems of inequalities. We've been working with equations. Now we're going to work with inequalities. So you have to remember that an inequality is going to use these, less than or greater than symbols. We're not going to have an equal sign in there anymore. And you guys might be kind of wondering how this works pertaining to a graph, but it's really not too bad. So the first thing, it says a solution to a system of inequalities has to satisfy both inequalities. So that's one big thing. It has to make both true. So let's decide if the following ordered pairs are solutions to the system. So what we're going to do is we're just going to take these x and y coordinates and we're going to put them into these inequalities to see if they're true. So I'll do the first one. I'm going to put a 7 in for the y and a -3 in for the x. And when I simplify that, this gives me 12 plus 1 is 7 less than or equal to 13. Yes, it is. Okay. So then I'm going to do the other inequality, and I'm going to put, it goes 2 times -3 plus 3 times 7 is greater than 11. So this gives me a -6 plus 21 is greater than 11. -6 plus 21 is like subtraction, so I get a 15. Is 15 greater than 11? Yes. So is this a solution? Yes, it is. Okay, so let's check the next one. I'm going to put a 1 in for my x and a 5 in for my y. So I get 5 is less than or equal to -4 times 1 plus 1. 5 is less than or equal to 4 plus 1. 5 less than or equal to -3. Is this true? No. So do I have to do the next one? No, because it has to be both inequalities. That's the big thing here. So I'm going to go on to the next one. I'm going to put x, y. So I get 5 is less than or equal to -4 times -2 plus 1. 5 is less than or equal to 8 plus 1. 5 is less than or equal to 9. Is that true? It is. So then we're going to check my other one. I get 2 times -2 plus 3 times 5 is greater than 11. So this gives me -4 plus 15 is greater than 11. This gives me is 11 greater than 11? No. If there was an equal sign underneath, we could say yes, but this is a no. So this is not a solution. Our next one, I'll put the 17 in for the y, and then the -4 goes in, and 17 is less than or equal to 16 plus 1. Is 17 less than or equal to 17? It is. It's equal to. Then I'll do the last one here. 2 times -4 plus 3 times 17 is greater than 11. This gives me -8 plus 3 times 17, I think is 51. I better just double check my math. 17 times 3, yep, 51. So this gives you, subtract those, you get 43 is greater than 11. Is that true? It is. So is this a solution? So we just checked 4 numbers. And the thing that I want you to, there are a ton of numbers, a ton of ordered pairs on there. How could we ever figure out the solutions? Okay. Well, this could get kind of tricky, and so let's start by substitution and elimination. Let's see if we can come up with anything here. So if you look here, you would maybe use substitution and you'd put it in there. But the thing is, it says y is greater than this expression, not equal to. So that's tricky. And then if you would try to use elimination here, we'd subtract this and you would have 9x. Then what would you do here? These are different signs. They're not the same signs. So how could we do this? Well, we actually can't, okay? So it seems like we can't solve these algebraically, and that's true. The only way you can solve these is to graph. Okay, so now you guys should be really good at graphing these. And so there's just a couple things that I need to teach you that is different, that makes inequalities different than regular equations. So first thing is the symbols. So if you have a greater than or less than with a line underneath it, you are going to have a solid line. If you do not have a line underneath it, you are going to have a dashed line. So this is kind of equivalent to the filled in circle or the not filled in circle. So maybe I will jot these off to the side here. So these ones, you're going to have a nice solid line. But if we have you're going to have a dotted line. So you can make that little note. So this one, type, it's a solid line. Okay, because it's this, and then it's a greater than symbol. So this means that you're going to shade above the line. This is a less than symbol. So this means, and there's no equal underneath it. So this means it's a dotted. And then it's a less than, so you are going to shade below the line. And trust me, I know this might seem really confusing to you right now. How do you do above or below a slanted line? I'm going to show you a couple tricks that I have. So we're going to do the first one. This one is the positive 1/3. That is this line right here. And so notice that it's solid. And then it says shade above. And so what I do is I will sketch a couple perpendicular arrows. And notice how my arrows are going up. That means that it's above. That line doesn't seem too bad. Okay, but your other line says it's a dotted line and you need a shade below. Well, if I drew a perpendicular line off of here, notice how my arrows are going down. So that would mean below. Now, I didn't do any shading, and the reason I didn't shade yet is because I shade my solution. Okay, and that is the area where both my arrows cross. So if you look here, this region right here is the region that both of my arrows cross. This one only has blue, this little area here has none, and then this one only has the green. This area in between those two lines has both blue and green arrows, so that's important. So then it says, which of the following ordered pairs are solutions to the system above? And what you're going to do is you're just going to check really quick which ones make it true. So the first one, 0, 1. So 0, 1 right here. Yep. -4, 1. -4, 1. Yep. 3, 2. 3, 2. No. -2, +4. 1, 2, 3, 4. Well, it's right on the line, and that's kind of tricky, but it's a dotted line. So what that means is it does not include the line. So that's a no. If it was on the solid line, it would. So let's try another one. 6, 0. So 6 and 0 right here. So yes. And then -78, 5. How could we figure that one out? Well, if we went out, I mean, if you visualize this, you're going out -78, and we were up to +5 right here. Do you think if we stayed there, it'd include that? Yes, it would, because it's going to keep going higher that way. So 5 is always going to be true from this point on. 0, -2. 0, -2 would be right here. and that's going to be a yes, because it's right on the line and it's a dot. It's a solid line, not a dotted. And then the last one is +3, -1. And this one's tricky. It's right here. So this is the thing. It's a solution to the solid line inequality, but it's not a solution to the dotted line inequality. So it's a no. Okay, and I know that seems maybe kind of confusing. You could always check by putting these into the equation. If I put this into that dotted line expression, I'd have -1 is less than -3 + 2. This would be -1 is less than -1. Is that true? No. So that kind of shows you how that doesn't work out. It has to make both true, and that's the biggest thing coming from there. Okay, so now we're going to do some practicing, and we're just going to graph both lines just like I did in that first example, and we're going to find the shaded region. Okay, so my first one, my line is +2. I always love doing these for some reason. I think because I like graphing. -2/3, so down 2/3, down 2/3. You have to have your ruler, and this is going to be a dotted line, and I know that because there's no line underneath my inequality symbol. So I'm just going to make my dotted line going across here. And then this is less than, y is less than, so I'm going to shade below. So when I draw my arrows coming off, they should be going down. Okay, so now I'm going to do my other one, and this is y is greater than or equal to x. Remember that if there's nothing with the x, there's a 1 here, and there's a 0 here. So this is going to be a +1 as my slope. And it's going to be a solid line because it has that equal to symbol underneath. And then this says y is greater than. So that means that my arrows should be going up. Okay, so now I'm looking for that region that they both includes both of them. Basically, this is split my graph into 4 regions. Nothing over here, only green in this region, only blue in that upper region there. So if you look here, the region that has both arrows is right here. So that's your solution, because any point in here would make both of them true. Okay, so I have, next one, I have -1, and my slope is a -1, so I just go down 1 over and down 1 over 1. It is a solid line. Oh, and then it's less than, so I'm going to go below. And then my next one is going to be y is less than -3. Now, picture this, y equals -3. What that means is it's going to be a vertical, or not vertical, a horizontal line at -3. So 1, 2, 3. And it's less than, so it's going to go below this line. And so I'm going to go down. Oops, sorry, that should have been a dotted line. Dotted. Sorry, I was so focused on going the right way. I don't think I have my white out either. So what region does it share? It looks like, obviously it doesn't share this region, nothing up here, not this little region, but it shares this. You can see where my edges are. Okay, now if you were doing this in pencil, you could just shade that area in pencil, but you do need to make sure that I can tell which one is the shaded region. Okay, we're gonna do another one. Starting with -3. 1, 2, 3. Positive 3 over 1 is my slope. Positive 3 over 1. And then it says it's a dotted line, so I'll make this one dotted this time, like I should have. Okay. And then it says it's greater than. So remember, if you're drawing lines at a 90-degree angle, they should be going up. If I drew them this way, they'd be going down. Then my other one starts at +1, and it's a -2 over 1, so -2 over 1, -2 over 1. This one is also a dotted line. Okay. And then it is greater than, so I need to be going, my arrows, if I draw them off here, need to be going up. And then I am going to shade the region that they share. So looks like not here, not over here, not here. They share this little wedge right between the two lines. Okay. Hope you guys are feeling pretty good about this. Our next one, we have kind of one of those special cases where it says x is greater than or equal to -2. That means it crosses my x-axis at -2, and it's going to be a solid line. It's going to be vertical. Now, on a vertical line, how do you decide positive or up or down? Well, it's greater than. So which side would be greater than -2? It'd be to the right. Okay. Then my second line starts at -4. So 1, 2, 3, 4. And it's a -5/2 slope. Well, sometimes you guys get stuck because you can't go down, but I can go up 5. 1, 2, 3, 4, 5, and then my negative can be 2. Now this is also a solid line, so I'm going to make that a solid line. It says below. Y is less than, so less than is down. Okay. So then what is the region that they share? Well, our graph is, again, split into 4 regions. This little wedge right here is the only spot that both of your graphs share. Okay, the next one, it's starting at 0. Your slope is up 4. 1, 2, 3, 4 over 1. This is a solid line because there's a line underneath it. And then it says less than, so it needs to be going down. Okay, and then the next one starts at +2. My slope is a +1/4, so up 1 over 4, down 1 over 4. And then it says it's greater than this, and this is a dotted line. So dash, 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 and it's greater than, so I'm going to go above. Okay, where's the region that they share? This little wedge right here. Okay, my next one, it has y is greater than or equal to 0. So this means it's going to cross the y-axis at 0, which would be right here. It is a solid line. It's going to be hard to see because it's right on that horizontal x-axis. But it says it's greater than, so it's going up. And then my next one is at +5. 1, 2, 3, 4, 5. My slope is a +4/3. I can't go up 4, so I'm going to go down. 1, 2, 3, 4. Then I also need to go over negative. 1, 2, 3. They both have to be negative if I want it to stay positive. Now this is a dotted line. So I do this dotted line, and then it's greater than, so that my lines have to be going up. It's going to go above. And then which region do they share? Well, okay, not below this line, not above, but right here. It's so hard to see on this graph. Okay. So once you graph it, then you would be able to answer questions like what points would make that equation true. Okay, so we're going to explore some more things. What happens when lines are parallel? Okay, so we've already graphed these lines for you. What you need to do, and if you look, they're all the exact same lines. The symbols, the inequalities are just different. So we are, obviously the top one is the first equation, the bottom one is the second equation. And so we're going to graph these really quick together. So this one, y is less than that top equation. So we would shade below. And then the next one, y is greater than the -2 equation. So this would shade above. Okay, so what region do they share? Well, they share everything in between, right? Okay, next one. Y is greater than the top equation. Okay, y is also greater than the bottom equation. So the region that they share is right here, not in between. Okay. The next one, y is less than the first equation, so that would be going down. And y is less than the second equation, so that one is also going down. So it's only below here. And then the last one, y is greater than the top equation, and it is less than the bottom equation. Oops, my arrow is going the wrong way. So on that last one, what happens? This is a no solution on this last one. So sometimes that happens on those ones. So sometimes they have regions that they share. Sometimes those regions are, these graphs aren't split into 4 quarters anymore. It's just above that first line, and this one's just below that second line. So sometimes those are the limiting things. Okay, I know this video is getting long. We've got 4 more problems. We're just going to write the systems of equations. Doesn't matter which equation you do first. So focus on just the y-intercept and the slope first. So I'm going to do my solid line on this one first. So y, my intercept is +2. My slope, it looks like it's a -1/3. So -1/3, and I'm shading above, and it's a solid line, so greater than or equal to. My second line crosses at -2. And also would have to be shading above this line in order to have that area count. And it's a -2, and my slope is, looks like a +1. Up 1 over 1, up 1 over 1. Okay. So this region, if you look here, I'd be shading above the dotted line, but below that solid line. Doesn't matter which one you want to do first. I'm going to do that dotted line first. It is a y, because it crosses the y-axis at 2. So it's greater than 2, but not equal to, because it's a dotted line. My other equation, it crosses the y-axis at -1. And my slope, this one is a less than, or equal to, because it's solid. And my slope, let's see, down 1, 2, 3, 4 over 1. So it's a -4 over 1. Okay, this one, I'm shading below the dotted line, but above the solid line. Doesn't matter which one you do first. Let's just do this one. So y is greater than or equal to, my slope is, go here, 3 over 1, so 3x, and it crosses at positive 2, 1, 2. My other one is going to be less than, so y is less than, not equal to, because it's a dotted line. It crosses at negative 2, and my slope is, looks like the cross is here and here, so down 1, right 4, so negative 1/4. Last one, it looks like you have the shade below on this one, and also below on this one. Those arrows just really help me. They are both dotted lines. Doesn't matter which one I do first. I'll start, they both have the same intercept, so y is less than, y is less than. They both start at positive 2, but they just have different slopes. So this one has a slope of down 1, 2, 3, and over 2. And then the other one has a slope of up 1, 2, 3, over 2. And there you go. So that's how you do the reverse. Okay, if you guys have any questions, make sure to let me know. You have the following 2 pages for your homework. And I hope you guys are having a great day.